In this video, I'm going to be going over dream drilling, mainly in clearance for ejector pin holes, but then also drilling ejector pin holes. If you don't know much about dream drills, they are incredible. They're made out of carbide. If we have shrink fits, so they work amazing. You don't need to worry about a sealed collet and it pushing out when you're using through spindle coolant. And they run incredibly fast, even in P20, which is roughly about 32 Rockwell. So let's get started. So let's open up our B plate. And also, if you didn't know, they drill to size. So I wouldn't go above a 5 times D for drilling to size, but a 3 times D is kind of where I really like to stay when I'm drilling the land for an ejector pin hole. So what that does is I actually can drill from the face. There's no, you don't waller out the top of the hole. You can just drill straight through, and then there's no reaming from the back to get the pin to size, or that hole to the pin size. So it's really nice, really efficient, and it's just so fast. So as I said before, let's get started. So we're going to go ahead and create a new UCS. So in dream drilling, when you're using anything above a 5 times D, so YG1 really recommends that you use even a 3 times D to spot an 8 times D drill. So I really don't like starting with 8 times Ds. If you do it from the face for an ejector pin hole, you will waller out the hole, you will make the hole bigger, and you will have a little bit of flash. So in this, we're going to go ahead and do this. So I'm going to be drilling 9/32 holes for the 1/4 inch dream drill ejector pin hole. I'm also going to bring in the spot drill. Okay, so the 3 tools that I'm going to be using. First off, I'm going to be using a 140-degree spot that lines up with what the drill angle for the dream drills is. You don't want to be using a 118 or even I think it's a 132 or 136. I can't remember. I think it's 132. You want to be using that 140. So that just guarantees that you are on location, and especially since these are solid carbide, I mean the 15 times D that I'm going to be using is I mean you can drill 4.2 inches deep, and that's solid carbide, so that's not a cheap drill. And so you want to make sure that you are being as accurate as possible so that there's no walk whatsoever. So I'm going to be using the 140 degree spot. I'm also going to be using a 9/32 3 times D YG1 Dream Drill. That is DH406018F. And then the last tool that I will be using is the 9/32 15 times D YG1 Dream Drill DH515018F. So I'm going to go ahead and actually change that to 20 thousandths. We're going to spot drill. My clearance is good. There's that 140. Hole center by diameter, which is going to be a 0.2813. Go face view. All right, so these are two different depths. However, you're going to be, both of them are pretty deep. You really won't need to know the exact depth, except to know that you aren't overextending your dream drill. See, from there to there, it's 4 inches. Okay, perfect. So, because you don't want to go too much above that 15 times D, which is equal to 0.281 times 15 is 4.215. So you don't want to go too much above that. So this is going to be our 3 times D. Our 3 times D, we're only going to be drilling 2 times D. And this, we're going to be doing spot drill. So in order that it goes all the way straight through, there's no pecking, it just goes straight. So these are all numbers that I have talked to YG tech support about for what we're doing, our application, and I can give you the times because I've already ran this plate. And I can put a video in afterwards showing that I ran this plate at these speeds. So our drill points, hole center 281. All right, we're gonna go back to face. All right, so all of these are gonna be drilling 562 thousandths deep. All right, here's when things can start getting a little complicated. So in this, so we don't just do a normal drill. You have to do an automated drill cycle. Just takes a second to load. All right, I'm gonna go ahead and open up or make sure. And if you see my sets tab going in and out like that, I have a hotkey for that. So just know that. So our part surfaces, you're gonna window all of that. So and it only will, with the automated drill cycle, it'll highlight all the holes that you are able to get from the UCS that you have. So as you can see right here, these are all gray. It means that you can't get them. All right. So now we're going to go into Group Manager. So this is the hole selection process. So we don't want to select any of these holes. We just want to select the 281 holes. So we're going to go ahead and do face view. But first I am going to hide this face so I can actually see what I'm doing from the side. All right, I'm just going to select all of these, all of these, all of these, and these. All right, so in this, there are 2 different depths. Come on. Okay, and it's not letting me hide the surface. There it is. Okay. So this one is a lot shorter, or not a lot, but a little bit shorter than this one is. So you have a blue and a red. All of these are the same. All of these are the same. So let me just look at this really quick. All right. So from this stage, what you do is you go over here to your unassigned groups. So we're going to double click this one and drill into this. So the first thing that you need to do is go new cutter. And it's the 15 times D. So first thing you're going to adjust, you're not going to do spot drill, you're going to do gun drill. So your top reference is ST. I'm going to change this to actually 0.1. And your bottom reference is going to be your B, and we're going to do full diameter. I'm just going to go a little bit deeper than what that edge is. That's fine. All right, so first thing we're going to do is access our feeds and speeds calculator. Again, these numbers are from YG and they work amazing. So we're going to go 4.5 for our feed per revolution, and then for our SFM, we are going to go ahead and do 180. So we're going to be, our feed's going to be 11 inches a minute. and our speed is going to be about 2,400, a little over. So that's our feed and spin calculator. Then we're going to access this. All right, so what this does, you're probably going to need to either have an engineer at your company or talk to Cimatron and get a post that works the way that you want this to work. So the way that we're going to have this work is, so first it's going to be our pilot depth. So we've already piloted with that 3 times D at 2 times D. So our pilot depth is going to be 0.3. That's just going to be what goes in to kind of guide it a little bit before it gets to the guide depth. Our guide depth is going to be 0.2. So positioning, our spin, I want it roughly a little under 30% of what our spindle speed is to lower drill whip, because I don't want it wallering out the top of that hole, which would actually dull the drill. So I'm actually going to do 680, which is like 27, 28%. I'm going to make sure my coolant is off. I don't want my coolant on, because if your coolant is on, it's going to be pushing it down into that hole, and it's going to be coming back up at the drill, and again, could cause drill whip. We don't want that. So we're still going to keep it at that 680 for our pilot. And a lot of times you actually want this. I need to actually revisit this topic and make sure that the air turns on to kind of blow away all the chips, to make sure that your drill doesn't come down on a chip and break some of the carbide. That's obviously not good. So our feed is going to be at 50% during our pilot depth and also our guide depth. So while it's guiding, again, the coolant's going to be off. We're actually going to change it to through at this point. Then we're going to change it to through on this parameter as well. This is going to be a blind hole. There's not going to be any intersection. We have tried this with water lines before, using a 7/16 dream drill, and then also a a 343 drill for a 1/8 inch pipe tap as well. Couldn't remember the fractional value of that for a second. Still can't, but when you're doing intersection, when you're intersecting other holes, it creates a lot more wear on the drill, and for how big those drills are and how much they're worth, it's not worth it. The cost to time benefit, it honestly, it kind of equals out, but then you also need to spend a lot of time in making sure everything is working right, versus when you're just using high speed drills for water lines, it's just a little bit more mindless. So we have tried to go down that route, but and in certain scenarios, like when you aren't actually intersecting any holes, it's fine, but I would recommend this mainly for ejector pin holes and clearance. So we don't need to do any kind of backup distance. So, and then on our retract, however, we do want to slow it back down to that 680. Our feed, it's fine. We can just put it to 70%. And we actually are going to make sure that our coolant is turned back off. So the reason why you need to talk to somebody about the post is that it does all of these specific things that you're trying to do. So when it's positioning, is it going to change the speed? Is it going to turn the coolant off? Is it going to then turn up the speed to, oh, okay, so our guide needs to be at 2446. When it's guiding, is it going to change the feed rate? Is it going to turn the coolant off then back on, and so on and so forth? So you need to make sure that it's doing all of these things, and I'll show you a picture, or I'll show you what the post actually looks like after this. I'm just reviewing these numbers and making sure that they all look right. And they do. So the one thing that I am going to change is this dwell. So whenever it does change speeds, I'm going to have it dwell for 1 second. So there's that first one. And then this unassigned one here. we're going to say again, new cutter, 281, 15 times D. We're going to access this, do that 4.5 thou chip load and the 180. Same thing. You can click this right here and it'll show you what it's doing. All right, and see, that's good. We're going to access this, and a lot of these parameters kind of copied from the last one. So 680, cooling off at 50%. Again, you do want that 50% feed rate while you're going into the hole. So blind hole, retract 70% feed. You don't want it to wrap it out of the hole for drill lip as well, and that's why we're feeding out of the hole at 70%. So this one's good. We can go and save and calculate. So the reason why this is so much more efficient is because you don't have to peck whatsoever. When I ran this, I drilled, including this 3 times D at 2 times D of depth. So both of these combined for a total of 32 minutes, for a total of 116 linear inches. So which is just stupid fast. That's so much time that you are saving when you are instead of just using a high-speed deep hole peck. You can save a whole lot of time. When I was researching this, my question was, okay, well, how long can this drill go for? So this drill now, and when I talk about linear inches for this drill, I don't count the pilot. So I count from from where it actually starts drilling all the way to its finished depth. And we've drilled about 700, a little over 700 linear inches with this same drill before it's needing sharpened. So we're just about to send it out, but still, that's a lot of time saved. In those two videos, it showed exactly what we wanted it to do. So it first piloted in the first video, and then it used the second long dream drill in the second video to finish out the hole. So if we go into here, now I can show you kind of more step by step, and now that you actually know what you were looking at in the numbers. I'm also going to pull up the post and go side by side. So the post is right here. Okay. So you can follow along on the left side or the right side. So spindle speed there, it positions, that's just the height offset. It goes to 0.1 in Z, turns off the coolant right here, goes down to that negative 0.3, then goes down to that negative 0.5, the addition of these two, ramps up the spindle speed, still at the same feed rate though, so it didn't change that, and put this MO7 code, so there's that dwell. MO7 is the through spindle coolant. Went to negative 0.5. And then once it reached that depth, it turned on all these parameters and went all the way down to full depth of that hole. Then it slowed right back down here, dwelled for a second, turned off the coolant, and then came back up to 0.1, which is our DZ feed start, to prevent drill whip, and wallering out the top of that hole. So, and then went up to the clearance plane and did it all over again. So in the next video, I'll be going over the actual dream drilling from the face and what that looks like, because you also want to do it as close to the hole as possible. So how can you be accurate at that? So that'll be in the next one.